Hi everybody, welcome back. Again, video series on small engines. This segment has to do with fasteners, sealants, and gaskets. Engines, when they run, get hot. And when they get hot, they expand. And what doesn't work would be if we would try and bolt the head. Again, this is a head from a Briggs & Stratton engine. If we would bolt this directly on there, and this engine would expand, it's going to break the fastener. It's going to break this bolt off. So what the manufacturers have done, what we learned over the years, is use a gasket. And this is the head gasket. Notice it's got a metal ring on the inside. Again, that helps to seal it. So that when again, because all these engines are doing is they're harnessing explosions. You're using a chemical reaction that when the gasoline and the oxygen explode, the gases are expanding and it's pushing down the piston. This is what's helping to catch that explosion. In other words, if this wasn't in there, chances are some of it's going to leak out. So again, when the engine gets hot, it expands, and that's why the fasteners, the bolts, the head bolts, when they go through the head and tighten into the cylinder here, have to be at a specific torque, because what it does then is when this expands, it can squeeze this gasket. This is a Teflon gasket, and it's got metal inside of it too. But what it does is it allows it to squeeze it, but then when the engine cools back off again, it will allow it to shrink and still not lose the seal here. And just happens to be Teflon and metal. Here is the gasket that goes on the top of the head, and this is called the valve cover. Notice this one's cork. So the gaskets and all are made out of several materials. I've seen what's used a lot back in the village and all is Sailor Boy crackers. Man, they make great gaskets. It's incredible. I've even put those in as this gasket, and they'll work for a while. I mean, yeah, so whatever it takes to get it to work, right? Till you can get the manufacturers. Again, these are rubber or neoprene. These happen to be gaskets out of a Yamaha 700 engine for holding in between different parts of the engine, the crankcase parts of it, halves and all. And these are used a lot now, the rubber, the O-rings. Again, they're usually made out of neoprene. You'll see different colors for different applications. I think they go with the red or like for a high temp application, that kind of thing. Here's another application for a gasket sealant. You probably recognize this. This is a fuel pump from a snow machine. Notice it has a gasket here that's pretty well stuck on this side of it. This is the outlet where the hose attaches here and then attaches to the crankcase. And that's where you're getting the pressure difference from, the high-low pressure that's pumping the gas. Again, one of the things I want you to keep in your head through this video series is that science never sucks. That these things are working, this engine is working because of pressure difference. High pressure, low pressure. That's how this works, that's how the carburetor works, that's how airplanes fly. Here is the other parts, other gaskets that are inside of this fuel pump. And you'll notice that there are little flaps right here. See that right there? So all it's doing is, because of the high-low pressure, these little flaps are opening and closing opposite each other to catch the gas. So the chamber inside we'll get into this more too, the fuel pump becomes a high pressure chamber, and then when the piston moves, then it becomes a low pressure chamber. So it's just opening and closing with those little flaps. So again, just another example of where sealants are really important. And something else is maybe your pump got really old, and again, whoever this was anyway, see the corrosion in there. There shouldn't be corrosion in your fuel pump because you've allowed water in your fuel system. That's none of those things. Don't allow the water in your fuel system, and you'll have many, many thousands of miles of really fun riding. If you allow the water in your fuel system, you're going to have issue. Melted pistons, messed up crank. I mean, keep the water out of the system. I got a little experiment we're going to do too with that. I'll show you later on. So this is the chamber where this flap goes in and out, creating high and low pressure, and these little flaps go over these holes, and that's how, again, this this little gasket sealant is used to move the fuel. And if these surfaces get kind of roughed up, you can put it on a piece of emery cloth and redo it a little bit, clean it up some, and if need be, you can even use some of this and actually put a real fine amount on here. Put this back on, and a lot of times you can get it to work. It's pretty incredible. Pretty cool how that will work. Again, this is a Permatex, made by Permatex, and it's a silicone sealant. The phenomenal part about them is they're like oblivious to gasoline. Gasoline doesn't bother them a bit. It'll tell you on the back, if you read the back, it'll tell you the directions and how much to use. Most people way overuse it. Don't use near as much as you think you're going to. This is the one that could be used for this. This is the high temperature. In other words, if you have places like by your exhaust and all that requires I think it's like over 500 degrees. Use the red. How about if you have a fastener that you're afraid someday is not gonna want to come out of there? This is called anti-seize. And they have a aluminum based and they also have a copper based. I think the copper base is actually better. But again, that will coat the threads and go into the threads and say here, in this case, be in the cylinder. And it'll keep the bolt from seizing in there. And again, a friend of mine showed me years ago, he used to own a salvage yard, and I said, Gary, what would you use to put on the threads when you put this back together to keep the corrosion happening between the steel bolt and the aluminum, in this case, the cylinder? And it floored me. He said, get a bar of ivory soap. He said, fill the threads with ivory soap. I was like, what does that do? He said, well, it's a base. And he said, if you think about it, if you get it wet a little bit, it's slippery. And he said, what it really helps to do is cut down on the oxidation between the steel and the aluminum. Amazing how well that worked. Sometimes you don't want things to come apart. And I use this a lot, especially when I'm working on brakes. I use the thread locker. This happens to be a Permatex blue. There's a red. Red is the permanent. They say the red you're not supposed to be able to get apart again unless you heat it. And there's also a green that you can apply after the fastener's been put in that will soak in. It says it'll soak into the threads. Again, this is a product that is put on the thread, so when you put it together, it'll hold it there. And something else I think is really amazing about this is if you put this on, it also helps keep the threads from rusting because they're sealed. It helps keep the moisture out. Again, if you break one off, or if you strip the threads out, how are you gonna redo them? This stuff is amazing. Another thing I've done before, again, this is the JB Weld. It's an epoxy. You mix the two together. You can fill the hole back in and then re-drill it and tap it. Rather than have to buy the whole, this assembly, this crankcase and cylinder assembly, you might be able to fix it. Another thing I've done, which they make is really cool, is it's an aluminum brazing rod that melts at like 700 degrees. And you can actually put the bolt in. If the threads are stripped out, put the bolt in and then melt this with a MAP gas and actually get the bolt and everything hot and put the bolt right in there and let it cool. It'll make new threads and thread it out and you're good to go. And actually that brazing rod, and there's several different brands of it, the brazing rod then is actually stronger than the aluminum. So it's even stronger. So again, this is the end of the gasket sealants fasteners. And again, thanks for watching.